Hi everyone, today we're doing isomers. Our syllabus outcome is explore and distinguish the different types of structural isomers, including saturated, unsaturated hydrocarbons, including chain isomers, position isomers, and functional group isomers. So let's have a bit of revision first. Carboxylic acids contain a carbonyl group attached to an OH and in anoic acid. Amines contain NH2 and end in enamine. Amides contain a carbonyl attached to an NH2 and end in enamide. And amines and amides can also have other carbon chains coming off the nitrogen. Now, isomers. What's an isomer? It's a compound that has the same chemical formula, but a different structural formula. So there are three types of isomers that we're going to be studying, and these are the three that were in the syllabus dot point: chain isomers, position isomers, and functional group isomers. And now the key thing with all of these isomers is that they all have the same formula. Okay, whatever it is, an isomer will have the same chemical formula. So if it's C3H4O, for instance, then that will follow through. Okay, all the different isomers will have the same formula. Now let's have a look at the different types of isomers. Chain isomers have the same chemical formula, but the way the carbons are arranged in the chains is different. All functional groups are the same. It's just the parent chain that changes. Now, if we have a look at these are two chain isomers as an example. On the left, we have butane. On the right, we have 2-methylpropane. Both of them have 4 carbons. Both of them have 10 hydrogens, but they're arranged differently. Now, the reason this is a chain isomer is because the parent chain is different. So the longest continuous chain of carbon in the left-hand side is 4, so it's a butane. But on the right-hand side, it's only 3, so it's a propane. Here's another example. On the left, we have 5 carbons in a row with a single double bond. So that is a pentene. On the right, the longest continuous chain is 4. So it's a butene. And in this case, it's 2-methylbutene. Okay. So both of them have 5 carbons and 10 hydrogens. Both are alkenes, but the longest chain is different. Now, position isomers. Position isomers have the same parent chain, and that's the key thing. If it's a pentane, it's going to stay a pentane. Or if it's a propane, it's going to stay a propane. It's just that the functional groups or the substituents have moved around. All the functional groups are the same. It's just the position's different. Now, look at these. These are some propanols, sorry. Both of them contain 3 carbons, 8 hydrogens, and 1 oxygen. They're both alcohols. It's just that the alcohol's on a different carbon. On the left-hand side, it's propan-1-ol. On the left side, it's propan-2-ol. Okay, so it's just changed position. We can see that they're both propanes. The parent chain has not changed. They're both alcohols, so the functional group has not changed. It's just moved spot. Okay, so that's a position isomer. Now, here's another example. Both of the molecules above contain 6 carbons, 12 hydrogens, and 1 oxygen. Both of them are ketones, but the ketone is at a different position. So on the left-hand side, it's hexane 2-one. On the right side, it's hexane 3-one. So notice that the parent chain is still the same. It's still hex for both of them. Now, functional group isomers. Functional group isomers have the same number and types of atoms, but are arranged in such a way as to have a different functional group. The most common functional group isomers are ketones and aldehydes. The other one that we will see a fair bit later on is carboxylic acids and esters, but you guys don't know what an ester is yet, so I'm not going to talk about that. So here's an example. On the left-hand side, we have C6H12O, same as on the right. They're both C6H12O. But if we have a look at the one on the left, it's an aldehyde. The one on the right is a ketone. So this is one of the examples of a functional group isomer. So they've got different functional groups, they're different chemically, but they're the same number of atoms, the same parent chain, same number of atoms, just a different functional group. So this is one of those examples I was talking about between carboxylic acids and esters. So our carboxylic acid, so the one on the left is our carboxylic acid. It's got the carbonyl and an OH at the end of the chain. We can also have the carbonyl and oxygen in the middle of a chain. This is what constitutes an ester, and we'll talk about those at a later date. But these are also functional group isomers. So they should say functional group isomer at the top, not position. Basically, they're both different functional groups, but they've both got the same number of atoms. So let's have a look at these. Are the following molecules chain isomers, position isomers, functional group isomers, or are they the same molecule? Let's have a look. So the one on the left has 6 carbons in a row with a chlorine on the second carbon. The one on the right has 6 carbons in a row with the chlorine on the third carbon. Now, if we count them up, they've both got 6 carbons. They've both got 13 hydrogens and 1 chlorine, so they are definitely isomers. Okay. What type are they? Are they a chain isomer? Are the chains different? No. They're both 6 carbons long, so they're both hexanes. Is it a position isomer? Well, yes, because the chlorine has gone from 2 to 3, position 2 to position 3. So it's a position isomer. Is it a functional group isomer? No, because the functional group's the same. And is it the same molecule? No. They're different. So in this case, it's a position isomer. This one here, on the left-hand side, we have 7 carbons in a row. So it's a heptane. On the right, we have 5 in a row with 2 carbons coming off that center carbon. So they're both C7H16. So they are isomers, but what type is it? Is it a chain isomer? Well, one of them is a heptane, one of them is a pentane. So yes, it is a chain isomer. It's not a position isomer. It's not a functional group isomer. It's definitely not the same molecule. It's a chain isomer. What about this one? So on the left, we have propanal. On the right, we have propanone. Now, are they chain isomers? Well, no, they've got the same chain. They're both prop. Are they position isomers? No, because they don't have the same functional group. And that's where our correct one comes in. They've got different functional groups. One's an aldehyde, one's a ketone. So these are functional group isomers. This one. On the left-hand side, we have a chlorine on the second carbon, a bromine on the fourth carbon. On the right side, we have a bromine on the second carbon, a chlorine on the fourth carbon. But the way that we name it, these are just mirror images of each other. So these are actually the same molecule. Okay, the chain is the same, the positions are the same, the functional groups are the same. So they're not any of those isomers. They are the same molecule. Okay, it's just mirror image. If you take that one on the left, pick it up off the page, flip it over and put it back down, you'll get the one on the right. Okay, and that's how we know. So revision, this should say summary. Isomers are different arrangements of the same atoms. Chain isomers have a different parent chain, but the same functional group. Position isomers have the same parent chain and the same functional group, but have different substituents. And functional group isomers have different functional groups. Okay, that's all for today. Thank you.